Oh, so we've got now pretty much everything we need to tackle this question. And again, the question at hand here was, how many people should I sample in order to be very confident about the population's mean? And we've got this equation we're shooting for, the critical value, standard deviation for the population, and E, the margin of error. Then you square it. So these things, some of them, actually all of them, you get to decide on. And that's very empowering, but also a little terrifying. Fortunately, I've got here, and I'll go over it again real quick, a guide for what to do if you have no idea what to shoot for. Of course, if you're working problems out of the textbook, more often than not, they'll just straight up tell you. But if you have no idea what confidence level to shoot for, you're probably going to go for the 95% confidence level. And E, that's another thing. When you're picking sample size, you can choose, right? What would be a window or what would be an interval you would like to see? Personally, I want to be within a year either way. So I'm sorry, I want to be within half a year either way so that I will have my overall interval be 1 year, right? I want my final answer to be something like, it'll take 5 or 6 years on average or 4 to 5 years on average, right? That would make sense to me. So that's why I'm picking E to be 0.5 here. Critical value, we're pretty good with that. Comes off the t-table, and actually either the t-value or the z-value will come off the t-table. So 95%. I'm using population data here, so I'm going to take 1.96. And then finally, if you have no idea what the standard deviation should be, just ask yourself this. What's my range of values? Right? What's fast, what's slow, what's high, what's low. And you just take those two things, see how far apart they are, and divide that range by 4. So I said that a 4-year degree, a fast student will take 4 years to do it, and the slowest I could expect a student to take might be 12 years. So that gives me a range of 8. Divide that by 4. I've got a sigma value of 2 here. So now I've got E, critical value, standard deviation. That's all the things I need for this formula. So in goes critical value, sigma, E, and crunch those number time, and I get 61.4 people, and I can't ask 61.4 people, and 61 is not enough, so I have to round up to 62 students. That's what N should be here. So my conclusion is, if I take 62 people and random samples, not misleading questions, all that good stuff, I can be 95% confident that the confidence interval I would produce based on the sample data I get from those 62 people, that confidence interval will look something like X bar, give or take half a year. And that interval should, I'm 95% confident anyway, will contain the true population mean mu. That is what we conclude here. So if you want a higher confidence range, you would need to ask more people because a few things will change. Specifically, your z-score will go up, so you need to ask more people for that. If you want a tighter window, meaning you want a lower margin of error, that will also make you ask more people. But honestly, yeah, it's not that many people to get a good hip check here, a good shot from the hip here. And of course, remember, we did take a stab at standard deviation. So if you want to ask more people because, well, we did guess at standard deviation, then yeah, you should ask more people for that too. But yeah, that's this whole section, start to finish. Obviously, asking more people is never a bad thing, although it does cost money and time, and it does make you run the risk of getting bad data. But hey, if you are not confident that you've got enough data and your numbers back it up, then get more data. Just make sure it's good data. Make sure it's randomly sampled, no misleading questions, no biasing, all that good stuff. But as long as you do that, you can produce confidence intervals for proportions and now means as well. So in the next video series, we will start talking about variances, population variances. So I will see you then. Have a good one.